Here we have IIT JEE Main mathematics problem. Okay, let's go to the question. The sum of the squares of all the roots of the equation x square positive absolute value of 2x 93 94 equals to 0 is okay. For the given equation, we have to get the sum of the squares of all the roots. Okay, here when I look at the given equation carefully, it contains the modulus part, that is absolute value part. So now in my first step, what I have to do is I have to redefine this absolute value part as a piecewise function. Okay, for that, let's have some basic understanding of that absolute value stuff. Let me consider absolute value of some stuff like k. Okay, when I take modulus of any value, always it will result in a positive value. So always the absolute value of any stuff, whether it's positive or negative, or in case if the k is 0, then it will be 0. Okay, now let me consider some value inside the absolute sign, that is for example absolute value of positive 5. Here we have a positive number inside the absolute sign. What is the result of this one? It's just positive 5. Okay, now let me take 0 inside the absolute sign. So what is the result of this absolute value of 0? That's 0. Okay, now let me take a negative value inside the absolute sign. So what is equal to absolute value of negative 5? That is positive, that is positive 5. Okay, when I have a positive value inside the absolute sign, so it results a positive value. When I have 0 inside the absolute sign, it results 0. So when I have positive value or 0 inside the absolute value, so the result is the same what we have inside the absolute sign. What if we have a negative value inside the absolute sign? It results 5, which is opposite of this number we have inside the absolute sign. So this is a basic understanding we need to have on absolute value part. So based on the discussion we have, we can redefine this absolute value of 2x 93 as a piecewise function. So how we can redefine this one as a piecewise function? Let me take this absolute value of 2x 93. Okay, what if the value of this one is a positive or 0? That is when 2x 93 is positive, means is greater than 0, or it may be equal to 0. When the stuff inside the absolute value is either 0 or positive, it will result the same what we have inside the absolute sign, that is 2x 93. So the absolute value of 2x 93 equals to 2x 93 when this 2x 93 is greater than or equal to 0. And also we can solve for x in this inequality. Then I'm getting 2x greater than or equal to 3. And when you divide both sides by 2, I'm getting x greater than or equal to 3 over 2. So when 2x 93 is greater than or equal to 0, I'm getting x is greater than or equal to 3 over 2. That is this absolute value of 2x 93 equals to 2x negative 3 if x is greater than or equal to 3 over 2. That is 2x 93 is greater than or equal to 0. Okay, what if the value of this 2x 93 is a negative? Let me write the stuff over here. What is this? What if the value of this one is negative? If this one is negative, then we have to take opposite of this one over here as a result of this absolute stuff. That is a negative of 2x negative 3. So just consider this one. When we have a negative value inside the absolute sign, the result is opposite of what we have inside the absolute sign. Here I assume the value of this one is negative. Then the result of this absolute stuff is the opposite of this one, that is negative of 2x negative 3. So usually we get this result when this 2x negative 3 is less than 0. Now we can solve for x in this one, that is 2x less than 3. Then we get x less than 3 over 2. That is we get this result if x is less than 3 over 2. Okay, now I have redefined this absolute value part as a piecewise function. Anyways, let me erase the stuff and write this summary alone. Okay, here we have redefined this absolute value part as a piecewise function. Okay, now what I'm going to do is in the given equation, I'm just going to consider the first piece over here. That is when x is greater than or equal to 3 over 2, this absolute value of 2x negative 3 equals to 2x negative 3. Okay, now let me take the given equation. Before that, let me write the condition. That is the first piece. That is if x is greater than or equal to 3 over 2, then the given equation will become what? That is x square positive. And for this one, we have tried 2x negative 3. Let me write over here. 2x negative 3, negative 4 equals to 0. Okay, then we get x square positive 2x. When I combine this negative 3 and negative 4, I'm getting negative 7 equals to 0. Okay, this is a quadratic equation and we have to solve this quadratic equation. I don't think this quadratic equation can be solved by factoring. So we have to use quadratic formula to solve this one. Okay, let me quickly solve this one using quadratic formula. That is negative b positive or negative square root of b square. Negative 4ac over 2a, and we get x equals to negative. The value of b is a coefficient of x, that is 2, positive or negative square root of b square means 2 square, negative 4 times the value of a is coefficient of x square, that is 1, and the value of c is a constant, that is negative. 7 over 2a, that is 2 times the value of a is just 1. Let me continue over here. X equals to -2, positive or negative, square root of 2 square is 4. And when I multiply -4, 1 and -7, I am getting positive 28 over 2 times 1 is 2. Then we get x equals to -2, positive or negative, square root of 4 times 4 positive 28 is 32 over 2. Then we get x equals to -2, positive or negative, and square root of 32 can be written as 16 times 2 over 2, and -2, positive or negative. 16 is a perfect square. When it comes out of the square root, it will be 4. Then we have 2 inside the square root, 4 times square root of 2 over 2. And now what I can do is I can factor 2 out from these two terms. When 2 is factored out, then we get -1, positive or negative, 2 times square root of 2 over 2. Then this 2 will cancel out. Then I'm getting x equals to -1, positive or negative, 2 times square root of 2. Now we can split up this 1 into 2 solutions. So that is, one is x equals to -1, positive 2 times square root of 2, and other one is x equals to -1, negative 2 times square root of 2. Can I accept these two values as a solution for this quadratic equation we have over here? No, we cannot, because there is a condition. There is x has to be greater than or equal to 3 over 2. So only this value is greater than or equal to 3 over 2. That is greater than or equal to 1.5. And this is not greater than 3 over 2. So since this value of x does not meet the condition we have over here, we can reject this one. So we can consider only this one as a solution for the given equation. Okay, now I just consider the first piece of the stuff we have over here. That is when x is greater than or equal to 3 over 2. And I got a solution -1, positive 2 times square root of 2 for the given equation. Now what I have to consider is I have to consider the second piece we have over here and solve the given equation. Okay, now let me continue this on the next page, and let me take this equation again. And for this absolute value of 2x negative 3, I have to plug in this negative of 2x negative 3. Okay, let me do it. We have x square positive, and we have negative of 2x negative 3. Let me go to the previous page. On -4 equals to 0. Actually, we have this one when x is less than 3 over 2. Okay, now what we have to do is we have to solve this equation. So we hit x square, and when I multiply this positive and negative, I'm just getting negative 2x negative 3, -4 equals to 0. Now we can distribute this negative sign to this one and this one. Then I'm getting x square negative 2x. When I distribute this negative sign to this negative 3, I'm getting positive 3, -4 equals to 0. Then I'm getting x square negative 2x. When I combine this, I'm getting -1 equals to 0. Okay, again we have a quadratic equation. This quadratic equation cannot be solved by factoring. We have to go with the quadratic formula. Let me solve it by quadratic formula. That is x equals to -b. So the value of b is -2, the coefficient of x. Positive or negative, square root of b square. B square means -2, the whole square. -4 times the value of a is 1. The value of c is also, sorry, the value of c is -1, divided by 2 times a. The value of a is 1, the coefficient of x square. Okay, then we get x equals to negative times negative will become positive. That is 2. Positive or negative, square root of the value of this negative to the whole square is just 4. When I multiply this -4, 1 and -1, I'm getting positive 4 divided by 2 times 1 is just 2. Then I'm getting x equals to 2 positive or negative square root of 8 over 2. Then we get x equals to 2 positive or negative square root of 8 can be written as 4 times 2 over 2. Then we get x equals to 2 positive or negative. So 4 is a perfect square. When it comes out of the square root, it will be 2. Then we get 2 times square root of 2 over 2. Then I'm getting x equals to, we can factor 2 out from the numerator. Then I'm getting 2 times 1 positive or negative square root of 2 over 2. So this 2 will cancel out. I'm getting x equals to 1 positive or negative square root of 2. Now we can write two solutions. So one is x equals to 1 positive square root of 2, and the other one is x equals to 1 negative square root of 2. Okay, so according to the condition we have over here, the value of x has to be less than 3 over 2. That is, it has to be less than 1.5. Clearly, this value of x is greater than 1.5, because we know that square root of 2 is 1.414. When I add them, I'm getting 2.414. So this value of x is greater than 3 over 2. It does not meet the condition we have over here. but the value we have over here 1 negative square root of 2 is less than 3 over 2. It means the condition we have over here. So we can reject this solution. We can just consider only this solution. Okay, when I consider the second piece of the absolute part, I got one solution for x for the given equation, that is x equals to 1 negative square root of 2. Already I got a solution over here, that is negative 1 positive 2 square root of 2. I got two solutions for the given equation over here. But according to the question, what I have to do is I have to find the sum of the squares of all the roots. All the roots means the two roots of what we got. We have to square each root and we have to add them. Okay, now let me square this one and also let me square the one I got over here, and I have to add them. Okay, now let me do it on the next page. Okay, here I just squared each of the two roots and I added them according to the instruction we have in the question. Okay, here in the first one, let me write this positive value at first, and we get 2 times square root of 2, and we can write this negative value, negative 1, the square, positive. We can write this one as it is, that is 1 negative square root of 2, the whole square. Now what I have to do is I have to expand the square of this binomial and square of this binomial. For that, let me consider the algebraic identity, that is a negative b the whole square, which is equal to a square negative 2ab positive b square. Okay, we can use this expansion to get the expansion of the square of these two binomials. Okay, now let me compare the first one with this a minus b the whole square. At the place of a we have 2 square root of 2. At the place of b we just have 1. So in this expansion on the right side, for a we have to write 2 times square root of 2, and for b we have to write 1. Then let me do it. That is 2 times square root of 2 the whole square, negative 2 times square root of 2 times 1 positive 1 square. This is the expansion of the first one. Okay, now to get the expansion of this one, at the place of a we have to use 1. At the place of b we have square root of 2 over here. Then I'm getting 1 square negative 2 times 1 times square root of 2 positive square root of 2 the whole square. Okay, so here 2 and square root of 2 are multiplied, and we have the exponent 2 in common. Whenever two values are multiplied and have exponent in common, what we can do is we can take this exponent separately for each value and multiply the results. Then I'm getting 2 square times square root of 2 the whole square, negative when I multiply this 2 and 2 times square root of 2, I'm getting 4 times square root of 2. 4 times square root of 2 times 1 is again 4 times square root of 2. Positive, the value of 1 square is just 1, and the value of 1 square is just 1. Negative, when I multiply these three values, I'm getting 2 times square root of 2. So here square root and square will cancel out. I'm getting positive 2. And here the square root and square will cancel out. I'm getting the value of 2 square is 4. 4 times 2 is 8. Negative 4 times square root of 2. Positive 1, negative 2 times square root of 2, positive 2. Okay, now what we can do is we can combine the like terms. So here I can combine this 8, 1, positive 2. So when I combine them, I am getting a positive 12. When I combine this negative 4 square root of 2, negative 2 square root of 2, I am getting negative 6 times square root of 2. Now, what is the greatest common divisor of this 12 and 6 times square root of 2? That is 6. So we can factor 6 out from this expression. If 6 is factored, what do we get inside the parenthesis? For that, we have to divide these two values by the one I factor, that is 6. When I divide this 12 by 6, I'm getting 2. Negative. When I divide this one by 6, I'm getting square root of 2. Okay, now I got the sum of the squares of the two roots of the given equation, that is 6 times 2 negative square root of 2. Okay, now we can go to the answer choices and check it. Let me go to the question. Okay, we get 6 times 2 negative square root of 2 in answer choice C. The correct answer choice for this question is C.